Hi, welcome back to this channel. So in the previous session we had discussion over the properties of sulfuric acid. What are the physical property and how it act as a good reducing agent and all that. And also we discussed about the physical properties of sulfuric acid. Okay, under the physical property of sulfuric acid, it is denser and shows more specific gravity and what is the freezing point and boiling point and all that. Okay, next the very important concept of sulfuric acid, that is chemical properties of sulfuric acid. Okay, under the compounds of group 16 elements H2SO4 sulfuric acid, the preparation method was deducted. So you just for your knowledge purpose you can refer the book. Okay, the chemical properties of sulfuric acid. Chemical properties, how it is a good acid, on what basis you can give the justification. The acidity property of sulfuric acid, the acidity of sulfuric acid is justified when sulfuric acid is dissolved in water. What happens? Sulfuric acid is a good acid, therefore it readily gives the hydrogen or proton. So it gives a proton to water and protonated, water becomes protonated, it is called hydronium ion. Hydronium ion is generated. Actually it is a reversible, okay, and plus HSO4 minus losses one hydrogen. So this is the manner of or representation of the reaction. Sulfuric acid when dissolved in water, it is less reversible. You can show only forward direction, it's not wrong. Okay, hydronium ion HSO4 minus is formed. Here the reaction, for this reaction the acid dissociation constant. The meaning of acid dissociation constant is capacity or dissociation capacity of any compound, a hydrogen dissociation capacity. It is represented in terms of Ka. K is acid dissociation constant. Acid dissociation constant is more than 10. Okay, so it is more than 10. The any compound which shows more than 10 value, then it is strong acid. It represents acidic nature. Next, so whatever the quantity produced HSO4, it is actually diaprotic. Therefore, it has capacity to produce another proton H3O plus again SO4 2 minus. Another proton is removed from the compound. Okay, the HSO4, now it becomes SO4 2 minus. Okay, here the Ka value is nearly equal to 10 raised to minus 2. Because of that, it represents or it clears that acidic nature of this one HSO4 is very low compared to H2SO4. So the first dissociation or the proton first dissociate from H2SO4 is has more tendency compared to proton dissociated from HSO4 minus. So H2SO4 is a strong acid. So this is the evidence. Okay, you should know the reaction for giving the justification of acidic character of sulfuric acid. Okay, next we move on to the another chemical property, that is it could act as a good dehydrating agent. Okay, first property acidic nature, second property dehydration, property. Under dehydration property, sulfuric acid is made to react with sucrose C6, sucrose C12, H22O11. This sucrose solutions of sucrose or a glucose. So whenever the carbohydrates are made to react with sulfuric acid. Sulfuric acid is a good shows good dehydrating property here. So because of good dehydrating property, sulfuric acid consume all the water molecule present in the sucrose. So that get converted into a charring take place. Charring of sucrose take place. Okay. Charring means carbon remains. Okay. Whatever the water molecule, water H2O. So this quantity water molecule is evaporated. Only carbon remains. So only carbon remains means 12 molecules of carbon or atoms of carbon, sorry, here carbon atoms, and H2O. How many H2O? So the H22O11 means there are 11 H2Os. Okay, 11 H2O. So this is the reaction. So when concentrated sulfuric acid is made to react with the sucrose, charring of sucrose take place. Char means this carbon remains. Okay, black color formation is observed during this reaction. Whenever glucose or sugar, when sugar is treated with sulfuric acid, so black colored precipitate is formed, charring is formed. So that is the evidence, or that is the observation we observed during the reaction of sulfuric acid. This one is due to the dehydrating property. Sulfuric acid is a good oxidizing agent. Sulfuric acid is a strong acid. Sulfuric acid is a good dehydrating agent and also a good solvent. Okay. So next, so this reaction is very important. As per your exam point of view, this reaction is very important. Okay. So how to represent this reaction and what type of question arises during in your exam when such type in this case H12 C12 H22 O11 here it is represented concentrated H2SO4. So what are the product formed? So this is the one possibility, and the next is give the example or give the evidence for the dehydration property of sulfuric acid. Give one reaction or give one chemical equation and like that. And another possibility, represent the charring of sucrose or represent the charring of glucose. If you consider a glucose, then 6 molecules of carbon will formed because it contains 6 carbon. Okay, so you should remember the number of molecular formula of glucose and sucrose. These two are required for giving the example. Okay, next, reaction with metals. How it reacts with metal? When copper is react with concentrated sulfuric acid, it forms a copper sulfate. Copper sulfate is formed. Okay, what are the other things remaining in the reaction? Hydrogen gas is evolved. You already well know when metals react with an acid, it gives hydrogen gas, or hydrogen gas evolved during the reaction between metals and acids. Also react with the non-metals. Okay, also react with the non-metal. How it react with non-metal? You can consider another example also, magnesium or iron and all that. Non-metals like sulfur. When sulfur is react with sulfuric acid, what may be the product? The products are sulfur dioxide and water. Sulfur dioxide and water is formed. Okay, here there are two S, therefore 2 into 2 4, water H2O. Okay. Suppose we consider a 2 here, 2 plus 1, it becomes 3, 3 into 2 6, 4 into 2 8. Okay, now it balances in the balanced chemical equation. What happened in this case? When sulfur is made to react with sulfuric acid, or solid sulfur is or sulfuric acid is made to react with the solid sulfur, then it gives sulfur dioxide and water. The white fumes is evolved. White fumes is nothing but the sulfur dioxide. Okay. Carbon also ability to react with sulfuric acid. Okay, just try to write the reaction. I don't write the reaction, complete reaction. Okay, just I give the hint here. Carbon, when carbon is made to react with sulfuric acid, carbon dioxide is formed because oxidizing agent. So sulfuric acid is in, these two are the evidence of oxidizing agent also. It acts as a good oxidizing agent. It oxidizes sulfur into sulfur dioxide. Here it oxidizes the carbon into carbon dioxide. Sulfuric acid is made to react with the carbon, then the carbon dioxide is formed. Okay, one, and another case sulfur dioxide is formed and water is formed. Okay, just complete the reaction. Okay, and balance the reaction. This work for you. Okay, because I already read the same reaction here, the oxidation property of sulfuric acid. So these two are the example of oxidation reaction. Okay, so for these cases, metallic reactions, there is a one general reaction is also there. Whenever any metal reacts with sulfuric acid, then it gives metal sulfates and hydrogen. Okay, so this is a general reaction for all metals. Okay, if it contains +2 oxidation state, then it's right. Okay, then +1, then just difference we observed here too. Okay, 2 molecules is required. Okay, here also we should represent 2. So this is a general reaction when metal is react with sulfuric acid, and here suppose what happened when any halide, metallic halide MX, okay, react sodium chloride like that, react with H2SO4. What happened in this case? Again metal sulfate is formed and HX is evaporated. Okay, so it is for the general reaction for metal halides. Okay, here we should consider this one is 2 and M2SO4. For example, okay, I'm considering one example for this case. Sodium chloride, or you can consider calcium chloride also. Calcium chloride is 2 molecules is not required. Sodium chloride is react with H2SO4, then sodium sulfate is formed and HCl gas is evaporated. Okay, so this is the evidence, or sorry, this is the example for metal halide react with sulfuric acid. Okay, that indicates sulfuric acid is ability to react with all type of non-metals, and to oxidize the non-metal, and also ability to react with the metal halide. So any economic of a country is measured using how much sulfuric acid is consumed per year. So that indicates the industry, complete chemical industry, it depends upon the sulfuric acid. It has that kind of property. Okay, so because of that also, the sulfuric acid is called a king of acid. Okay, so the whole economy of any country is measured using the quantity of sulfuric acid consumed per year. Okay, so that kind of property we observe. Here also we observe the all kind of reactions, good oxidizing agent, good dehydrating agent, good acid or strong acid. It has ability to oxidize the metals, non-metals and non-metals, and react with metallic halides. So all kind of reaction we observe. Okay, next, what are the uses of sulfuric acid? Uses is not important for your exam, but knowledge purpose we should know. A little bit uses are given in your syllabus. It is used in petroleum industry for refining purpose. Refining means purification purpose. Okay, purification of petroleum products. Sulfuric acid is used, and in aircraft, again in aircraft, sulfuric acid is used. And sulfuric acid is a good solvent in all industry in all type of industry, paint industry, dyestuffs, and medicinal related pharmaceutical industry. So all in all type of industry, chemical industry, we observe the uses of sulfuric acid. Okay, in a laboratory also we observe good, it acts as a good oxidizing agent and ability to shows a dehydrating agent. So in all that cases also sulfuric acid is used. Okay, so these are about the uses of sulfuric acid and the property. Okay, this completes the group 16th elements. Okay, next we move on to the group 17th elements. 17th elements, we study about 4 important elements. There are 6 elements, but 4 are very important. Okay, then what are the elements present in group 17? The group 17th elements are fluorine, chlorine, bromine, iodine, and acetylene, and tennessine. So tennessine and acetylene is not important, not much important. Okay, so these are the radioactive elements, and the last one is also, last one element is artificial element. Okay, therefore the study of fluorine, chlorine, bromine, iodine is very important. As usual, for remembering purpose, the elements of group 17 is memorized or remind using one funny word, that is funny sentence is first class biryani in Australia. Okay, so first class biryani in Australia. First because fluorine F and class chlorine, biryani bromine, in iodine, and acetylene Australia. Okay, so then what are the atomic number and what are the general properties of these elements and about occurrence? So all these things we studied under this category. Okay, the first thing is what is the atomic number of this element? Okay, atomic element is start with 9. Okay, 9. Fluorine has atomic number 9. Next, plus 8 plus 18 is 35, plus 18, 35 plus 18 which gives 53, plus, sorry, yes, 8, 18, 18, 32. Okay, now it is 81. Okay, so these are the atomic number: fluorine 9, chlorine 17, bromine 35, iodine 53, and acetylene 85. So these are the atomic number. Then what about the occurrence of these elements? The occurrence, about when you observe the occurrence, most of all these elements are salt borne. Salt borne. Salt borne means they exist in the form of a salt. These elements mainly occur in the form of salt, and also the most of the quantity or most of the salts, they are present in the seawater, the sea salt borne. So because of that, the one for this group 17th group elements is also called as halogens. Halogen is derived from a Greek. Halo represent or give the meaning of salt, and gens the bonds are formed, obtained, and all. Halogens is nothing but a salt-borne elements. Okay, so that indicates what type of existence and occurrence is there in the element. So most of the elements are salt-borne because of they are known as halogens. Fluorine, the fluorides, apatites, fluorides, so and cryolites, so that they exist in that form. Fluorides are mainly calcium fluorides like that, CaF2. So in case of a cryolite, so aluminum sodium fluoride, So it is exists in the form of AlNa3F6. Okay, this it is known as cryolite. So these are the ores or existence of the fluoride. And chlorine, you already well known about the chlorine, I think. So it is mainly exists in the form of sodium chloride and potassium chloride, chili bitter and Indian bitter. So these two are the different salts we observe. And bromine is also exist in the form of a salt, different salt, sodium bromide, calcium bromide. So the most of these all elements exist in the form of a salt. So it is about occurrence. The fluorine and chlorine, these two are the most abundant when we compare to the element present in the 17th group. Only these elements. When we compare only these elements, fluorine and chlorine shows more abundant in the atmosphere, and the existence of a bromine, iodine is a less quantity. Iodine is also present in the sea water, chloride is also present in the sea water, fluorine also present in the water. So most of they are present in a sea water. So it is about occurrence. The occurrence is not important for knowledge purpose. How to extract from these elements and how to obtain these element, and most quantity of the element is present in seawater, okay, or obtained from seawater. Next, the very important thing is atomic property. Okay, this one is general property. Next one is atomic property. Under atomic properties, there are four important atomic properties are observed. The first one is atomic radii. Atomic radii. How atomic radii is varies? Atomic radii. Atomic radii, when we move down the group, atomic radii increases. Okay, volume is increases because of the increasing the number of electron. When number of electron is increases, number of orbital increases, number of orbital increases, the volume increases. So on that, the atomic size is increases. Okay, next is electronic configuration. The second property, electronic configuration. What about the electronic configuration of these elements? These elements, what is the common electron configuration? So it is present in the 17th group. One electron is required to represent the electronic configuration of the next noble gas. Hence the common electronic configuration is Ns2 Np5. Only one electron is required to show the stability or the electronic configuration of the next noble gas. Here, when we use the noble gas electronic configuration core, the helium is next is S2, 2s2, 2p5, 2 plus 2 plus 5, 9. Okay, so 9 is the atomic number. Helium 2s2, 2p5 is the electronic configuration of chlorine. Next, electronic configuration of the chlorine, neon 3s2, 3p5. Next, argon 4s2, 3d10, 4s2, 4p5. Krypton 4d10, 5s2, 5p5. Next, last one is xenon. Here we observe the F 4f14, 5d10, 6s2, 6p5. So this is about the electronic configuration of these elements. Okay, when you observe the electronic configuration, on that basis also we can give the stability, oxidation property and all that. Therefore the study of electronic configuration and reminding the electronic configuration is very important. So please note it down and just practice on the writing the electronic configuration. So in PU level, if you are well known about this, then other thing will be easy. Okay. So these are about the electronic configuration. Next, based on the electronic configuration, the next property is, first one is atomic radii, second is electronic configuration, next is ionization enthalpy. Okay, ionization enthalpy. What is the ionization enthalpy of these elements? When we observe the ionization enthalpy of these elements, when we move down the group, it is completely dependent upon the size. When we move down the group, size increases. Because of that, ionization enthalpy decreases. When we move down the group, ionization enthalpy decreases. When we move down the group, ionization enthalpy decreases. Okay. Next, it shows more ionization enthalpy. Okay, more ionization enthalpy along the period in the P block. Okay. Next is electron gain enthalpy. Very important. Okay, electron gain enthalpy of this group is very important. Electron gain enthalpy. What is the electron gain enthalpy of these elements? Electron gain enthalpy. First of all, what is electron gain enthalpy? Energy released when electron is added. When we add the electron to the fluorine, some quantity of energy released, that measured in terms of a negative value. What is the reason of negative? The energy released. Because of that, we use the loss of energy, negative. More the negative value, more is the electron gain enthalpy. In the P block element, chlorine shows highest electron gain enthalpy. Chlorine shows highest electron gain enthalpy. According to the concept of electron gain enthalpy, fluorine should show the more electron gain enthalpy, but it can't happen. What is the reason? The reason is fluorine is very smaller size. Because of the smaller size, it does not show any tendency to attract the electron. Because of that, we need more energy to add the electron. Okay, so here when we add electron to fluorine, fluorine is smaller size. Due to the smaller size of fluorine, it does not show any tendency to attract the incoming electron. Because of that, we need some energy to add the electron. At that time, energy is lost. Energy is lost from our side or from the another metal side or atom side. Because of that, the released energy goes to fulfill that energy. So, electron gain enthalpy of fluorine is smaller. Small negative value. But chlorine shows high negative value. Chlorine size increases, so it has ability to take the electron. When you add one electron, then when you add one electron, it become 3p6. 3p6 is the complete or stable electronic configuration. Chlorine always tend to shows the p6 electronic configuration. Therefore, always try to catch electron. So when you add the electron directly, it attracts the electron and more amount of energy released. What is the reason? It gets stability. The stability comes after the loss of energy. So it loses its energy and becomes stable. More amount of energy released. So because of that, chlorine shows more electron gain enthalpy. Okay. So some differences is observed. Okay. Fluorine does not show more electron gain enthalpy, but electronegativity of fluorine is very high. Okay, electron gain enthalpy, fluorine shows more electron gain enthalpy. Next, electronegativity. Electronegativity. Electronegativity of the 17th group element or group 17th element. Fluorine shows highest electron gain electronegativity. Because of smaller size, it has tendency to attract shared pair electron, not a single electron. What we talk in this case, electron gain enthalpy, single electron, addition of single electron. Here the attraction of shared pair of electron during the bonding. During the bonding, fluorine has more tendency to attract the shared pair of electron. Because of that, fluorine shows more electronegativity. Here is fluorine, here is fluorine. So this is about the atomic properties of group 17th element or halogens. Okay, next is the physical properties. Okay. Under the physical properties of group 17th elements, okay, under the group 17 physical property of group 17th elements, the first thing is the physical state. Fluorine, chlorine, these two are gases. Fluorine, chlorines are gases. Next one, bromine is liquid. It exists in liquid state. And iodine and acetine, so these two are exist in solid form. They exist in solid form. We observe the variability in the physical state of group 17th elements. The first two are gases, next one is liquid, next two are exist in solid state. Okay, next is the coloring property. Metallic property. What is the metallic property? So these are the non-metal. Last one is metal, radioactive. Okay. In the coloring property, here we observe the very important thing. Halogens are color. Okay. Halogens are color elements. What is the reason of coloring property? The reason is because of the electron excitation. Here we call it as electron excitation. The reason is electronic excitation. What is the reason of the excitation of electron? When we observe the electronic configuration of these elements, here I am just going to take the one example. Here P5. Okay. P5, how these are arranged? What is the capacity of P6? So this is the way of representation of the P5. After P5 we observe the D. Correct? So we observe the D. There is a possibility of excitation of these electron to D. The electron present in the p orbital that excited to d orbital because of the presence of the d orbital very next to the p. When small amount of energy is available, then the p electron excited to d. What happened after that? When light is falls on the halogens, it absorbs the quanta energy and it excited to d orbital and come back to again p with the elimination of radiation. That radiation has some different wavelength. Because of that we observe the different color. Then what are the different color? Fluorine shows yellow, chlorine greenish yellow. It is a greenish yellow color. Okay, next. So it is because of electron excitation, very important. Okay, for your competitive exam, this concept is very important. Okay, the reason of coloring or showing the coloring or showing the coloring property of halogen is because of not DD excitation or not PP excitation. It is because of electron excitation from P to D. Okay. Next, chlorine, bromine is red color, and the last one, iodine, shows violet color. Okay. Yellow, greenish yellow, red and violet. So these different color is observed in the halogens. Okay, this is a very important physical property. We can't observe in other cases. In the P block elements, only halogen shows coloring property, and all transition element shows coloring property. That part you already well known in the D and F block elements. You have studied the coloring property of D or transition elements. That is because of the DD transition. Here we observe the excitation of electron. Okay. Next, solubility. Solubility. What is solubility of halogens? Halogens are mainly fluorine and chlorine. Okay. Fluorine and chlorine directly soluble in water. Others also soluble, but not completely. Okay. Readily soluble. Fluorine and chlorine are readily soluble. Because of that, we come across the fluorine water, chlorine water, that type of words. Correct? So fluorinated water, chlorinated water. It's because of solubility of fluorine and chlorine. Chlorine and chlorine shows the solubility in water. Small quantity of fluorine and chlorine, suppose is dissolved, is more than 100 ppm, then it becomes a fluorinated water and chlorinated water. So fluorine and chlorine is soluble in water, and bromine, iodine and all halogens are soluble in organic solvents. They all are soluble in organic solvents. Organic solvents like benzene, carbon tetrachlorides, like that. Okay. In case of carbon tetrachloride or benzene, so when we use a benzene and carbon tetrachloride, such type of solvent, then halogens are completely soluble. So this is about the physical property. So what are the physical property? First two are gaseous, next liquid, and other two are solids. Next it shows coloring property because of excitation of electron. And fluorine is yellow, chlorine is greenish yellow, bromine is red, iodine is violet. In solubility, fluorine, chlorines are readily soluble in water, and other all halogens are soluble in organic solvent. And first four elements are, these are non-metal, and the acetine shows small metallic property. The reason of non-metallic, so there is no availability of electron to conduct the showing the conducting property. Okay, so this is about the physical property. In the next class we will discuss about the chemical property. There are several chemical properties and anomalous behavior of fluorines there, so that part will be discussed in the next video. Okay, thank you for watching.